Okay, 4.1, this is when we start doing factoring. And factoring just means to undo multiplication. We are going to be writing the polynomial as a product. And the first thing we're going to start with is the greatest common factor. And the greatest common factors just means the biggest number that will go into all the groups of numbers, or the biggest variable that go into the groups of numbers. And so that's what we're going to start with today, is the greatest common factors. So let's go ahead and start with finding the GCF of 4x squared y and 18x squared y to the 6th. Now this first example is not going to be anything like all the other examples. We're just kind of looking at the two groups, not as a polynomial, but just individually. So I have 4 and 18. What is the biggest number that will go into both 4 and 18? Well, 4 will go into 4, 4 will go into 16, but it won't go into 18. So let's look at factors of 4. 4 has factors of 2. Will 2 go into 18? Yes. So the GCF for the numbers will be 2. Well, let's look at the variables. I have an x squared and x squared. When you're looking for the GCF for variables, and I'm going to write this down for you. It's going to be the variable with the lowest exponent for your GCF. So whichever variable has the lowest exponent, that's going to be the one that is the GCF. So if they have a variable common to both groups, then you can find a GCF. It has to be common to both of them, or all three, or all four, however many groups you have. And if you have it in all those groups, then the one with the smallest exponent is going to be your GCF. So we have an x squared in both groups, so x squared is going to be my GCF. That's the smallest exponent out of the x's. For the y's, I have a y to the first and a y to the 6th. Y to the first was going to be my GCF because it's the one with the smallest exponent. So in this first example, all we're doing is saying, hey, this is the this is the GCF. Now we're going to learn how to factor out the GCF. So when you factor out the GCF, you actually have it in a polynomial form. In our first example, we were just naming it. So to factor out the GCF, we still have groups. The terms are your groups. So in my first group, I have 7x, and in my second group, I have 14. So for my numbers, 7 and 14, what is the biggest thing that will go into both 7 and 14? It cannot be any larger than your smallest number. So that means 7 will go into 7, and 7 will go into 14. So 7 is my GCF for my numbers. Now let's look at the x. We only have an x in the first group. We don't have an x over here, so the x cannot be a GCF because it's not common to both groups. So what I'm doing is I've factored out a 7. And now I'm going to show you what remains left. If I take out a 7, what's left in that polynomial. 7 will go into 7 one time, and I'm only left with x. 7 will go into 14 two times. So this is how you factor out your GCF. Once you figure out what your GCF is, you divide this number into each term in that polynomial above, and that tells you what's left. Now you can always check your answer by distributing. 7 to the x gives you 7x, 7 to the 2 gives you 14. If you don't get what you started with, you factored out the wrong number, or you've messed up somewhere in your division. All right, let's look at our second one. For b, I have 7x minus 3x squared. 7 and 3. There's not a GCF other than 1 for those numbers, so I'm not taking out anything. For my variables, I have an x in both groups this time, x to the first and an x to the second. The one with the smallest exponent is going to be my GCF. So the only GCF I have for this one is just an x. So if I take out an x for the first group, I'm only going to be left with a 7 because I'm kind of canceling that x out. When I'm taking out an x for this one, let's bring down that minus 3. If I take 1x from 2, I'm only left with 1x. Okay? So when you're actually dividing your x's or your variables, it's kind of like the quotient rule. You're subtracting them. So I had 1, I'm taking 2, I had 2, I'm taking 1 away, and I'm left with 1. So it's a subtraction, unlike the division with the numbers you're dividing, with the variables you're subtracting the exponents. Okay, let's look at the next examples. Still doing the GCF. So 14 and 21. 14 won't go into 21, but let's see what the factors of 14 is. 7 and 2. Will 7 go into 21? Yes. So 7 is going to be my GCF for my numbers. And for my variables, I have an A in both groups, but I don't have a B in both groups. So let's look at, see if we have a GCF for our A's. The one with the smallest exponent, a to the second, is going to be my GCF for my variables. So how to get the remaining polynomial? 7 will go into 14 2 times. The a squares are going to cancel out, so 2 is the only thing I have in my first term. 7 will go into 21 3 times. If I take 2 a's from 4, I'm just going to be left with 2, and that b comes down. So that's what's left. For our last example on GCF, we have 3 different terms. So that means I have 3 numbers and 3 sets of variables to look at. 6, 9, and 12. Something that will go into all these, the biggest number. 6 won't go into 9, so let's think. 3 will go into 6, 3 will go into 9, and 3 will go into 12. So 3 is going to be my GCF for my number. I have x's in all 3 groups, x to the 4th, x to the 3rd, and x to the 2nd. The one with the smallest exponent, x squared, is my GCF for my variable, x. And then y squared, and y to the 4th. I have y's in all 3 groups, so y to the 2nd, since that's the one with the smallest exponent, is going to be my GCF for my variable y. So now to get the remaining polynomial, I have 3 will go into 6 2 times. For my x's, 4 minus 2 is 2. The y's cancel out. So that's all I'm left with in my first term. 3 will go into 9 3 times. For my x's, I have 2. 3 minus 2 is just 1. The x to the first is going to be all that's left. And the y's cancel out again. I had 2 and I took away 2, so I'm not left with any. Bring down my plus sign. 3 will go into 12 4 times. For my variables, the x squares are going to cancel out. For the y's, I had 4, I took away 2, so I'm just left with 2. So that's your remaining polynomial. And we'll pick up on the next page with the next video.